There are several keys that will help you balance equations successfully. First of all, make sure you write your homonuclear diatomics as the correct molecule, not an individual atom. Homonuclear diatomics are those atoms that hate going solo. Now, sometimes they mix with other elements to make various compounds, but even if that element is by itself, it will still pair up as a two-atom molecule rather than be a bunch of individual atoms. So to balance equations correctly, you need to recognize which elements are homonuclear diatomics. The first homonuclear diatomic is the first element, hydrogen. The remaining 7 make this nice 7 shape with the spine running down column 7. There is definitely debate on whether astatine should be included. For my class, since our book for first year chemistry course includes it, we're going to go with that and keep astatine in the list. So when you have a homonuclear diatomic element in an unbalanced equation, go ahead and turn it into the correct molecule before you even start trying to count atoms and make them balance. For hydrogen plus oxygen yields water, recognize that hydrogen and oxygen are both homonuclear diatomics, so they will both follow the buddy rule. Write it as H2 plus O2 yields H2O before you start trying to fill in the blanks to make everything balance. For carbon plus oxygen yields carbon dioxide, only oxygen is a homonuclear diatomic. Change O to O2, but C can stay as it is. Now you can work on balancing the equation. The next key is that you don't change the compounds, just the coefficients. Let's say you're trying to balance hydrogen plus oxygen yields water. First, you realize that you have 2 homonuclear diatomics, so you write those down correctly. But don't be tempted to balance the equation by tweaking the subscripts so that H2O becomes H2O2. Yes, your equation is balanced, but it's a totally different recipe now. Instead of making water, you're making hydrogen peroxide. You will be very disappointed if you take a big swig of that when your experiment is finished. Remember, we know what recipe we're trying to figure out. You're not changing the ingredients of your recipe, just the amount of each ingredient. So you can change how many chocolate chips you put in your cookies, but you can't swap the chocolate chips out for coffee beans. You won't get chocolate chip cookies anymore if you do that. Instead, focus on the coefficients, the numbers in front of each element or compound. I find it useful to leave space or write blanks before each number. Each item is starting with a 1, but as you balance, you can fill in a different number. The next key is to start balancing with the elements that have the fewest appearances on each side of the equation. Consider this combustion formula for methane. Carbon shows up once on each side. Hydrogen is also on each side 1 time. Oxygen, however, is on the left once and the right twice. There are going to be more possibilities to consider when balancing an equation with 3 or more appearances, instead of one that just has 2 appearances, 1 on each side of the equation. Start by writing down your element counts. We have C, H, and O. There's 1 carbon atom on each side. There are 4 hydrogen atoms on the left, the reactant side, and 2 on the right, the product side. Finally, the reactants have 2 oxygen atoms while the products have 3. Remember, we want to avoid balancing oxygen as long as we can. Our hope is that if we balance everything else, we'll have gotten the equation to a point where the oxygen is already balanced or it is easy to see how to do so. Starting with carbon or hydrogen would work. Since carbon is currently balanced, let's look at hydrogen. In general, you want to change the smaller number to match the bigger number. That means I want the product side to have 4 hydrogens. Hydrogen is only present in H2O. Since there are 2 hydrogen atoms in each H2O molecule, that means 2 water molecules will give me 4 hydrogen atoms. But notice that changing the coefficient for H2O will affect oxygen as well. We need to figure out our new counts. 2 oxygens in 1 CO2 molecule plus 1 oxygen in each of 2 H2O molecules gives a total of 4 oxygen molecules. Since the oxygen count on the product side changed to 4, while the reactants still have 2, we want to jump back to the reactant side to see if we can get enough oxygen to balance. So we're looking for a way to make the left side have 4 oxygens. Since oxygen only appears in the O2 molecule on the reactant side, that's what we'll need to change. We want 4 oxygens. We get 2 in every O2 molecule, so we need 2 O2 molecules to get a total count of 4. Now our oxygen is balanced. Luckily, oxygen was hanging out by itself as O2, so we didn't change any other counts when we changed oxygen's coefficient to 2. So now, All three elements are balanced. Let's try another. Aluminum plus hydrogen chloride yields aluminum chloride plus hydrogen. I'm assuming you know your homonuclear diatomics so well by now that you automatically wrote H2 down like I did. But if you just put H, change it to H2 now. Looking at our counts, we have one of each element on the left, but on the right we have 1 aluminum, 2 hydrogen, and 3 chlorine. So we need to play with our coefficients to get a balance. Notice that aluminum is currently balanced, so there's no point messing with it right now. Either H or Cl would be a good choice of where to start. I'm going to go with Cl since it has the largest number, with 3 chlorine atoms on the product side. That means I want to make the reactant side match that 3. Since there is 1 chlorine in each hydrogen chloride, that means I need 3 HCl's to get 3 chlorines. Now we have a second balanced element, but changing HCl affected both H and Cl, so we better revise our counts. There are now 3 hydrogens on the left and only 2 on the right. We want to increase the hydrogens on the right or product side so that the count is also 3. So if we want 3 hydrogens, but we get 2 hydrogens with every molecule, we need 1.5 or 3 halves H2 molecules. This brings us to our next key. Don't fear fractions. Technically, fractions are not allowed in balanced equations. The good news is that we're not done balancing yet. Go ahead and stick with the fraction for now. We'll deal with it in a minute. It's time to check our counts again. Everything balances. Our only problem is that it isn't a proper equation because of the fraction. So while the first half of our key is don't fear fractions, the second half is don't forget to fix those fractions when you're done. Getting rid of the fraction is easy. Look at your fraction and figure out what the denominator is. You're going to multiply the entire equation by that denominator. 3 halves is 3 divided by 2, so the denominator is 2. Multiply the whole equation by 2. That will double each term, giving us our final equation. Let's do one more example, showing you that the next key is repeat the cycle until you're done. Even if it seems like you're making things worse, just trust the process and see where it takes you. The first thing I noticed with this problem is oxygen is all over the place. So I would rather work on anything else before tackling oxygen. Although there are a lot of elements here, 3 of the 5 already match, so that's pretty encouraging. For now. We can start with either potassium or hydrogen. I'll choose potassium. To achieve balance, I want to cause the potassium on the reactant side to change from 1 to 2. The only way to do this is to have 2 potassium nitrate molecules. Unfortunately, this messes with nitrogen and oxygen, so we need to revise these counts. While balancing potassium, we lost balance with 2 other elements. This seems like it was a bad choice. But just trust the process. Keep on swimming. Soldier on, or whatever cliche you want to use, and stick with it a little bit longer to see what happens. I still want to avoid dealing with balancing oxygen as long as I can, so let's focus on hydrogen and nitrogen. In fact, you might notice that they're buddied up on the product side. So we can change them both from 1 to 2 at the same time simply by increasing the coefficient for nitric acid, that's HNO3, from 1 to 2. So this step gave us 2 more matches, but we know we also altered oxygen, so we need to revise that count as well. And look at that. Being put off by the complexities of balancing oxygen and sticking our heads in the sand like an ostrich has paid off. The oxygen is now balanced and we didn't have to mess with it. In fact, the whole equation is balanced. So sometimes the process is 2 steps forward, 1 step back, or actually sometimes it's more 1 step forward, 2 steps back, but it will usually still work out in the end. The final key is to sweat the details. You don't want to conquer balancing equations and then get marked off for silly stuff. Always double check your final atom count to make sure a careless mistake didn't mess you up. If you have fractions as coefficients, get rid of them before writing your final answers. If you started with states of matter indicators in your equation, that's solid, liquid, gas, and aqueous, make sure you still have those. And finally, don't slip so much into math mode that you write an equal sign instead of an arrow for your chemical equation. These equations can get more complicated, but if you've got this down, you have a solid foundation for balancing equations in chemistry.